Alright guys, let's have a look at this worksheet. Essentially what we're doing is we're doing a tree diagram. Literally we roll a dice and it's either a 6 or it's not a 6. Like it could be a 2, 3, 4, whatever. I literally only care about the 6s. So we start here. Start. If I got a 6, the probability was 1/6. If I didn't get a 6, the probability was 5/6 because, you know, I didn't get it. So this is kind of getting a 6 is what we consider success, and not getting a 6 was a failure. So this is technically what we call a Bernoulli trial. Bernoulli trial. It has two options. Success, which for us is getting a 6, or failure, which for us is not getting a 6. What would be the probability of success then for this one? Well, yeah, it's kind of obvious. It's 1/6. What's the probability of failure? It's 5/6. But instead of calling this P, we're going to call it Q. And with Bernoulli trials, because there's only ever two options, Q will always equal 1 minus P. So we've done our tree diagram. That was actually fairly simple. Now we want to do these rows. Now, this is 0 6s. This is 1 6, 2 6s, 3 6s, 4 6s, and 5 6s. So having one roll and getting 0 6s, the probability of that, one roll, 0 6s, like there's literally only one option for that. So there's one option, and the probability was 5/6, wasn't it? Okay. What if we had one roll and we got 1/6? Well, this time it's going to be one roll and we've got 1/6 probability. Okay. Now let's have a look at two rolls. Probability of getting 0 6s from two rolls. Well, there's only one way to do it still. And we've got 5/6, and it's happening twice. Now let's have a look at the probability of having two rolls and only getting 1/6. So this time, two rolls, 1/6. So we could start off not getting a 6. Oh, I want to do this in pink highlighter. We could start off not getting a 6, but our next one would be a 6. So that would be 5/6 times 1/6. I'm going to enter this in, 5/6 times 1/6. Actually, I would like to do 1/6 first. 1/6 times 5/6. But there was also another option for this, because we could have had one to start with and then lost it. So then we could have had 1/6 times 5/6 again. So this comes out as two lots of 1/6 times 5/6. Okay, what about the possibility of getting 2 6s? Well, 2 6s, there was literally only one possibility for that. It was up this way, so it was 1 times 1/6 times 1/6. I'll make these blue. Well, now let's have a look at the probability. Now let's have a look at what happens when we roll it 3 times. So getting 0 6s when we roll it 3 times, well, that's still, there's only going to be one option, and it's 5/6 to the 3. Because we would have had no 6, not 6, not 6. So 5 6 times 5 6 times 5 6. There was only one way for that to happen. What about the ways for getting 1 6? Well, let's have a look. 1 6. So I could have rolled it at the start and then got not 6 and then got not 6. Or I could have not rolled it at the start, could have rolled it second and then not 6. Or I could have not rolled it at the start, not rolled it, and then gotten it. So there were 3 ways to do that. So that's 3, and each of those, you only had 1 6 to the 1, and you had 5 6. You times it by, there were 2 of them. Hopefully you're starting to pick up on the pattern here. Okay, what about, well, they've already done 3 rolls in getting 2 6s, so now let's have a look at 3 rolls in getting 3 6s. How many options is there? 3 rolls getting 3 6s. You're right, 1, 2, 3. There's only one option, and it's 1 6th every time. So this time it's 1 times 1 6th to the 3. Now let's have a look at what happens. Let me make this blue. Now let's have a look at what happens when we do 4 rolls. And we want no 6s. Well, you're probably already like, well, that's just going to be 1 times, because there's one way of doing it, 5 6, because we're not getting any 6s to the 4. You would be right. 4 rolls and we want 1 6. I'm going to go through this. 4 rolls and we only want 1 6. Well, we could have gotten it at the start. Okay. Or we could have gotten it second. Or we could have gotten it third. Or we could have gotten it fourth. So there's 4 ways to do that. I just want to tie this up. Okay. So there's 4 ways to do that. 4 times, well, each of them had 1 6 rolled, and the rest of the times we got 5 6 rolled. You should start noticing a pattern. Let's have a look at the 4 rolls and we're getting 2 6s. So, let's say we got them first 2. Okay, there's 1. Let's say we got it the first one, not the second, third, not the fourth. Let's say we got it the first, not the second, not the third, but we got it the fourth. Not first, did get it second. Hang on, we're getting 2 6s, aren't we? Did get it third, not fourth. Not first, did get it second, not third, did get it fourth. Not first, not second, did get it first, third, did get it fourth. Not first, not second. 1, 2, 3, 4, 5, 6. No, that's the only ways to get. Okay, so there's 6 ways. And each of those had 2 times we rolled a 6 and 4 times we did, 2 times we did not. 3 6s, well, that's going to be this, getting a 6 3 times is the same as getting it once. So that's going to be 4 times, well, 1 on 6 to the 4, 3 times 5 on 6 to the 1. And this is going to be 1 times getting 4 6s, well, that's 1 on 6 to the 4. Now, you should have picked up on the fact that the numbers we're coming up with, let me make this blue. The numbers we're coming up with as our pronumerals, we've got 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Pascal's triangle. 1, 5, 10, 10, 5, 1. This would be 5 6 to the 5. 1 6, well, we're only getting one of them. 5 6, well, we're doing it 4 times. 1 6 to the 2 rolls, and then 5 6 the rest of the time. 1 6, we're getting 3 rolls, which means it must have been 5 6 for 2. 1 6 for 4 rolls. 5 6 for 1 roll. 1 6 for 5 rolls. Now, these numbers at the front, 1, 4, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. I'd like to remind you that, for example, if we had 1, 4, 6, 4, 1, that row of Pascal's triangle is the same as 4C0, 4C1, 4C2, 4C3, 4C4, which is the same as we've got 4 things and we're choosing none of them. How many ways is there of doing that? Well, there's one way of choosing none of them. 4 things and we're choosing one of them. Well, there's 4 ways to do that. 4 things and we're choosing 2 of them. Well, there's 6 ways to do that. 4 things and we're choosing 3 of them. There's 4 ways to do that. 4 things and we're choosing 4 of them. There's 1 way to do that. Oh no, I've just stolen. There we go. So we've got our probabilities there. If we had a die rolled 12 times, the probability we would get 5 sixes, well, we've got 12 times, we want 5 sixes. So that's 12C5 for our first one. That'll give us the number of branches that could make that happen. And then the probability of getting the 6 each time is 1 on 6, and we've got 5 of them. And then, well, the rest of the time, the probability was 5 sixths, and we must have had 7 of them. If there were 5 times we got 6s, there's 7 times we didn't. Can I generalize my result? Yes. If I have n trials, then it's always going to be n, c, and it's r successes times, well, the probability of success in each trial is p, so that was like our 1/6. So that's p, and that's p successes, so it's happening r times. And then we've got, well, the opposite, 1 minus p, happening the rest of the times. And don't forget 1 minus p also equals q. That's it, that's the worksheet.